Hi! I understand that many of you actually requested for more teaching videos. So for physics, I've also picked up one topic that many of us struggle with. It's none other than electricity. Now, upcoming, you're going to see a person solving electricity questions, and they are exactly GCE O-level questions. Yes, you hear me correctly. I'm going to have a special guest that's going to teach you on electricity. So if you want to learn more about this chapter, I want you to subscribe to our channel and please click on the likes, okay? If it's a good video, you should click on the likes, right? And if you have any comments, feel free to leave it, okay?
We're back. Now let's attempt a question that will apply all the concepts that we have covered so far. Okay, so we have this circuit over here, all right, and this is the background. The circuit is powered by a 5-volt cell, so it's always a good habit to put whatever information you have in text into the diagram, all right? So 5-volt cell connected to 4 resistors, 1, 2, 3, 4. Both resistors Y has the same resistance, so this 2 has the same resistance, okay? A1 reads 2 ampere, so this reads 2 ampere, all right? A2 reads 0.5 ampere, and V reads 2 volts, okay? All right, let's have the current running through this so we can tell better, all right? So we're going to draw conventional current flow, so it's from the long to the short side, positive to negative. So on the main track, this is I1. I1 comes here. Once it hits this junction where it's 2 different pathways, remember how they connected? Parallel, all right? It will split into, let's call this I2, and this is I3, all right? Then comes back together, it is the same. It is still I1 and goes back, all right? So first question, find the current going through Y, okay, all right? A, current that is going through Y. Okay, so we know that from if A1 is 2 ampere, so I1 is equals to 2 ampere, all right? Okay, and this is 0.5 ampere. Remember, voltmeter have very high resistance, no current flows through. So I2 is 0.5 amperes. And we know that how current behaves in a parallel connection fashion, all right? So I1 is equals to I2 plus I3. So if I1 is 2, I2 is 0.5 plus I3. I3 is equals to 1.5 ampere, all right? So this is 1.5 ampere, which is the current that is flowing through Y. So that is your first answer. Second one, B. Okay, find the PD across each resistor Y. Okay, so this is a conceptual question. Okay, we know parallel connection, we learned that potential difference is the same. So the PD across this whole thing is actually 2 volts. Okay, what are they asking? They're asking the PD just across one of them. Okay, so you have 2 resistors here that are exactly the same. If crossing over both of them requires 2 volt, what is the effort or work done to cross one of them? Common sense question, you just divide it by 2. So V across, or should I say PD across Y is equals to 2 divided by 2 equals to 1 volt. That's the answer. They're just testing on your concept. Concept understanding is very important. Yeah, the cap drop, don't mind it, okay? All right, C. What is a PD across resistor X then, okay? So this entire circuit, all right, there is the potential difference on this part and the potential difference on this part, all right? And the entire thing is powered by EMF of 5 volt. So if going across this part is 2 volts, and we have a total electromotive force of 5 volt. So what is left for this? Okay, all right. So EMF is equals to PD, all right. Let's call this whole part A plus PD B. Let's okay, B. Yeah, actually X will be better. All right. Okay, so PDA is 2 volts. EMF is 5 volt plus PDB. So PDB is equals to PD across your X is equals to 5 minus 2, you will get 3 volts. That's it, all right? So I hope through this simple problem, okay, actually this might be a full mark question, full 5-mark question for your paper, you will understand the main concepts of current and potential difference in parallel and series connection. Till the next video.